2012 Canadian Open Mathematics Challenge Part B. Alice and Bob run in the clockwise direction around a circular track, each running at a constant speed. Alice can complete a lap in t seconds, and Bob can complete a lap in 60 seconds. They start at diametrically opposite points. When they meet for the first time, Alice has completed exactly 30 laps. Determine all possible values of t. Okay. Well, throughout this question, of course, we're going to use that famous speed is equal to distance over time, and any variations such as time is equal to distance over speed. And we have some clues given to us in the question, and we will put that in a table. So when they meet, if this is Alice and this is Bob, this is the speed, the distance, the time. When they meet, the time is the same, right? So whatever the time is, it will be the same for Alice and Bob when they meet. Now the distance, we have to figure that out. The distance for Alice is 30 laps. So that's been given. Now each lap is going to cover a circumference of the circle. So I'll denote circumference with a c. So 30c is the distance for Alice. Now for Bob is interesting because if Bob is faster than Alice, that means he actually goes a half a lap more, right? Because he's starting over here. So in order for him to catch Alice, he would have to eventually always be half a lap more in terms of his distance. So he would be 30.5 c. However, if Alice is faster than Bob, then that means that Alice travels half a lap more than Bob, and therefore Bob travels half a lap less. So that means Bob would therefore be 29.5 c. So there's two scenarios, right? One is when Bob is faster, and one is when Bob is slower. And then the speed, of course, we don't know the speeds quite yet, so I'll just call it SA and SB. All right, so that's basically the question in tabular format. So here we go. Let's work with this now. So when Bob is faster, let's calculate that first one. Okay, so speed is equal to distance over time. So time is equal to distance over speed. And the two times are the same, right? So the time for Alice is her distance, which is 30c, over her speed, which is SA. And that's going to be equal to the time for Bob, which is d over s, which is 30.5 c over the speed of Bob. Okay. Now the speeds, of course, speed is equal to distance over time, correct? And they told us in the question that Alice can complete a lap in t seconds. So that means that if that is true, that one lap, which is the circumference, just c, is completed in t seconds. So that's the speed of Alice. Just c over t, where c represents the circumference. Now the speed of B, in a very similar way, we can figure out, which they're saying Bob is completing a lap in 60 seconds. So he would be c over 60. So there you go. There's SA and SB. Okay. So plug that in. This is 30c. SA, we just got c over t. This is 30.5 c. And SB, we got c over 60. So 30c over 1 times c, invert and multiply and you get t over c. And on this time, we get 30.5 c over 1, 60 over c. So the c's cancel, so all you're left with is 30t and then 30.5 times 60. And that looks like t, that will be 2 times 30.5, which is 61. So there you go, that's 1 time. And then in a very similar way, we would do the other scenario, which is when Bob is slower. The calculation will be identical. It'll be 30 c over t. But instead of 30.5, we have to use this 29.5 this time. So 29.5 over c over 60. And then this is very similar, invert and multiply. 29.5 c over 1, invert and multiply 60 over c. Yeah. And then all we're left with is 30t is equal to 29.5 times 60. And therefore this looks like t is 29.5 times 2, which is 59. So there you go. Those are the 2 possible times that satisfied the requirements of the question. For each positive integer n, define symbol n to be the number of positive divisors of n. For example, symbol 10 is equal to 4, since 10 has 4 positive divisors, namely 1, 2, 5, and 10. Suppose n is a positive integer such that symbol 2n is 6. Determine the minimum possible value of symbol 6n. Okay, so I'm going to show you something that you may already know. Let's say I have some number n, and its prime factorization is x to the power of a times y to the power of b. And I ask you, how many prime factors does this have? How many factors, not necessarily prime? How many positive divisors? How many positive divisors? Well, there's a very easy way of doing this. All you have to do is just take that a and add 1, and then take that b, add 1, and then multiply them together. So this would be the number of divisors. So for example, let's say my n was 3 to the power of 4 times 5 to the power of 6. Now, keep in mind, x and y must be prime. This is the prime factorization. And I asked you, this number, how many divisors? Well, you take that 4 up here, add 1. Then you take this 6 up here, add 1, and then you multiply. So that's going to be 5 times 7, which is 35. So this number has 35 positive divisors. So it's a quick way of doing that. So that's the concept we have to use again and again in this question. So they have initially told us that the symbol alpha, whatever, 2n is 6. So that means that 2n has 6 positive divisors. So if we represent 2n, for example, like I did over here, x to the power of a, y to the power of b, that means that a plus 1 times b plus 1 is equal to 6. Okay, so how can we do this? Well, there's a few ways. 6 is 2 times 3, really. 3 times 2, 2 times 3, same thing. So that means that a, it could be 2, and b could be 1. That's one way of doing it. That's one way of this being possible. So that would mean x to the power of 2, y to the power of 1. That would be one scenario. Okay? Now, if that's the case, that means we now have to look at 6n. Okay? So let's do that. 6n. 6n is what? 6n is really 3 times 2n. So we have 3 times 2n, but 2n is this, which is this. So that's really 3 times x to the power of 2, y to the power of 1. Now 3 is to the power of 1. Now they're saying how many positive divisors are there of that? Okay, well that's pretty easy. You take that 1, add 1. You take that 2, add 1. And you take that 1 and add 1. So now this is what? 2 times 3 times 2, which is 12. Okay. Now, but here's the thing. They're saying the minimum possible value. I've gotten one possible value for the number of divisors. If I use that symbol format, I've gotten one possible value. That's 12. But they're saying, what's the minimum? Is 12 the minimum? Well, let's see. Let's figure out what other scenarios. This is assuming that x and y are not 3. So this scenario is assuming that x is not equal to 3 and y is not equal to 3. But what if one of them was equal to 3, right? Like let's say x was equal to 3. Then what will happen is that this would be a little bit different. It would be 6n, which is 3 times 2n, which would be 3 to the power of 1. X is 3 now, so it would be 3 to the power of 2 times some y to the power of 1. This actually becomes 3 to the power of 3 times y to the power of 1. Now, if we use our system for the number of positive divisors, it would be that 3 up here, add 1, that 1 up there, add 1, and that therefore is what? 4 times 2, which is 8. Okay, now I've got 8 as my alpha 6n. That's pretty good, right? That's definitely lower than 12. Okay, let's keep going here. What about the scenario if y is equal to 3? What happens then? Can I get a lower number than 8? Well, let's see. This time we have 6n, which is 3 times 2n, which is 3 times, well, 2n is this guy up here. So x to the power of 2, and then y is 3 to the power of 1. So this becomes 3 to the power of 2 times x to the power of 2. Using our system for a number of positive divisors, this is going to be 2 plus 1 times 2 plus 1, which is 3 times 3, which is 9. So now my symbol 6n is 9. Okay. So far I've gotten 3 answers, of which the lowest is 8. And one more, I guess, way of doing this is something that some people might miss. It's not really that difficult to keep in mind, but some of you might miss it, so I'll just go through it. The last way is if 2 to the power of n, right up top there, was able to be factored with just one prime number. So for example, just x to the power of 5. Now the number of prime factors would be 5 plus 1, which is 6, which is exactly what they wanted, right? But this is only possible if x is equal to 2, because we already have a 2 there. So that means this has to be also a component of 2's. So that basically means that 2 to the power of n is equal to 2 to the power of 5. Okay, so that's the only way of doing this. So now our 6n would be 3 times 2n, which is 3 to the power of 1 times 2 to the power of 5. Now our system, 1 plus 1, 5 plus 1, and that's 2 times 6, which is 12. So that means our symbol 2n is 12. Okay, no problem. So now we'll look at all of our comprehensive possible values, which is what they wanted. We got a 12 here, we got an 8 here, we got a 9 here, we got a 12 here. The minimum of those is this 8. So that is the answer to this question. Given the following 4x4 grid, square grid of points, determine the number of ways we can label 10 different points, A through J, such that the lengths of the 9 segments are in strictly increasing order. All right. So they're saying that this, I guess, sequence or whatever is going to be in increasing order, and we will have to figure out how many different ways of there. The first thing to figure out is the lengths, right? So if this is A and this is B, that length is 1. And similarly, if this is B and this is C, that length is 2. So we have to figure out how many different lengths are there. Okay, that shouldn't be a problem. Let's see if I can do this here. That's 1, so 1 is one possible length. The next one, before I put them in increasing order, let me list them here. 1, 2 is another one. All the way across would be 3. And then we got to get into now diagonals. All right, diagonals. Okay, so this one would be, using Pythagoras, would be root 2. And I'll let you do that. I don't think you need me to go through Pythagoras for every single one. This one would be 1 plus 2 squared, which is 4. So that'd be root 5. Okay, any more? This one would be 1 plus 3 squared, which is 9. So that would be root 10. Okay. This one here would be 2 squared plus 2 squared under the square root sign, which would be root 8. Okay, any more here? I guess this one down like that. That would be 2 squared 4 plus 3 squared, so that'd be root 13. And I guess all the way like that, that's 3 squared plus 3 squared, which is 18, so root 18. Okay, so these are my lengths. These are my possible lengths. And there's 9 of them, right? Okay, so I've got to put them in order because this is an increasing order from smallest to largest. Yeah, from smallest to largest. So that would mean this is 1 root 2, 2 root 5, root 8. FG would be, I guess, 3, root 10, root 13, and then finally root 18. Okay. All right, so now that we've done that, we have to now start, assigning them. Okay, so let me just put this on a axis, XY axis, and I think that will be a little bit helpful. So there we go. All right, so let's try to do this now. This is the x-axis, this is the y-axis. Okay. So I'm going to start with the biggest one. So the biggest one is IJ. And that's obviously going to be the one that's, a diagonal. So I have some choices here. I'm going to start off with J here, which is 0, 0. I'm going to put the coordinates over here, otherwise the diagram is going to get very messy. And then I have to put up top here. So I's coordinates are 3, 3. All right, that's a pretty good start. But here's the thing. J could have been placed here or here or here. I placed it here. So there's 4 choices for J. So that is something that I definitely must, 4 choices for J. So that's very important. And that we'll need to take into consideration later on. Okay, now we've done that. We've done this. So we've taken that out of the way. Let's put a circle around it. Now HI is our next one. Now HI is root 13. So that means HI, I can put H here, right? Because that would mean that will be root 13 because it's going to be 4 plus 9. Okay, so that's fine. So that means H, the coordinates are, 1, 0. But here's the thing. I've actually got 2 choices. H could also go here because that would also make it root 13. So I'm not going to label it on the diagram, but I'll put it here. H could also be 0, 1. So I have 2 choices for H. 2 choices for H. All right, keep going. So now number 3 is going to be GH. GH is root 10, right? So that means I've got to put G at 2, 3. If H is here, right? Because I'm going with H being this 1, 0 guy. If it's 2, 3, then that means then G is up here. And that will indeed be root 10. Yeah. And based on where everything else needs to go, we cannot put G anywhere else, because it might be tempting to put it there also, but you'll see that F would therefore not have a proper spot, and you can try that on your own, but believe me that G has to go only there. So that means there's only one choice for G. 4, which is the next one, so we did GH, that's FG, and FG is 3. So it's got to be basically here, because that's just 3 spots. And that's the only place it can go. So F has the coordinates 2, 0. Okay, moving right along. The next one is EF. And that is equal to root 8. And in order to achieve that, we put E at 0, 2. 0, 2. So E goes here. All right. And then 6. Now we're at DE. DE, right? So D, that goes here in order to make that root 5. So that means D has the coordinates 2, 1. And so far, these are the only possible choices. It's not like I and H that had, 2 choices or 4 choices. Okay, next one, we did DE, CD. CD is equal to 2, right? So that means C, the coordinates, the only one that will fit is 0, 1. So C goes here. And then the next one is BC. BC is root 2. So that would mean B would have to be at the location 1, 2. So 1, 2. So B is up here. That's B right there. And then finally, the last one, AB. And AB is just 1. So A we can put, well, A we got a few choices now. We can put A as 1, 1, or 1, 3, or 2, 2. So obviously there's a few choices here. If you put A as 1, 1, A goes here, but it can also be 2, 2, which would be here, or it can also be 1, 3, which is here. So just keep that in mind. So that means that for A, there was actually 3 choices. So 3 choices for A. Okay, we're done. So all of these have one choice. So you don't really worry about them. But this one, there's 4. This is 1, there's 2. This one, there's 3. For all the others, there's only one choice. One choice here, one choice here, 1 here, 1 here, 1 here, 1 here. So the total of number of choices is 4 times 2 times 1 times 1 times 1 times 1 times 1 times 1 times 3. And this is 24. So 24 ways of creating these line segments in order to satisfy the requirements of the question. In the following diagram, 2 lines that meet at point A are tangent to a circle at points B and C. The line parallel to AC passing through B meets the circle again at D. Join the segments CD and AD. Suppose that AB is 49 and CD is 28. The length of AD is a positive integer, and determine n. All right. So before I begin, I'm going to draw just one line for now. I think I'm going to need a couple more lines later, but just for now, connecting C to B. And then later we can figure this out. Okay, so what did they give me in terms of my values? AB is equal to AC is 49. And the reason I know that AB is equal to AC because of that rule that if you have a point and it goes to the tangent point, and then you have another line from the same point to another tangent point, those two lines will be equal. So AB is equal to AC. That's a rule. And anything else they gave me, CD is 28. Okay. All right, so let's begin here. Okay, I'm going to label some angles. Since this is an isosceles triangle, this angle is the same as that angle, right? So that will be theta, that angle in there, and this angle also theta. Okay. Now this is an interesting because this line and this line is parallel. So by that fundamental principle, this angle is the same as that angle. So that means this angle in here is also theta. All right. And then we have one more angle. There's something called the tangent chord theorem. And the tangent chord theorem, if you apply it to this particular diagram, it will show that the angle ACB is equal to the angle BDC. So ACB is this angle right here, and that's equal to BDC. So BDC is that angle in there, and that's theta. All right, so we have done a pretty good job of labeling this. Now, since this angle and that angle are the same, that means that this is an isosceles triangle, where BC is equal to CD. All right, so that means we have a similar triangle situation. That triangle ABC is similar to triangle BCD, since they have the same angles. So therefore, if we use the ratio of the sides, AB over BC is equal to CB over BD. CB, BC, same thing, right? So let's plug in our values here. AB is 49. BC, well, BC is the same as CD, and therefore that's 28. So this will be 28. That'll be 28. And then BD, we don't know. Cross multiply, and you get BD is equal to 28 squared over 49. And therefore BD is equal to 16. All right, so that's pretty good. Very good finding so far. Okay, now we have to figure out AD, right? That is our goal. Okay, so now I will need to put in a couple more lines. So I'll put in one line that sort of extends AC. So extend it out a bit. And then drop two lines that are directly going to be perpendicular to that line AC. So the first one like that. Is that perpendicular? Yeah, it looks pretty perpendicular to me. And then one more from C going up to there, to the top, like that. Okay, so now let's talk about this. Since this is an isosceles triangle, when I draw a perpendicular line like that, it will cut the BD in half. That's just a rule. So this point right here is the midpoint of BD, and I'll just label it N, this point right there. And then this line was parallel to that line, right? And these two lines that I drew in, this one and this one, are perpendicular. So therefore, they're right angles right there. So that means this little guy here is a rectangle. So that means that N is midpoint of BD, and CM, well, this is M, ND is a rectangle. Okay, and then CM, therefore, is going to be the same as ND, which is a half of BD. And BD we just figured out was 16, so a half of 16, which is 8. Okay, great. So now we just have to use Pythagoras here a couple times. So first we used DM, CM, and DC. So this triangle here. So dm squared plus cm squared is equal to dc squared. So dm is what we're trying to figure out. So dc, did we figure that out? dc is 28. That's something that was given. And cm, we just figured out, was 8. Okay, so 28 squared minus 8 squared, 720. So therefore dm is equal to root of 720. Okay, I think just one more Pythagorean theorem and we should be done figuring out AD. And that's this big guy right here, that triangle. So that means AD squared is equal to AM squared plus DM squared. Okay, well, AM looks like AC plus CM. AC was 49, and then CM is 8 all squared plus DM squared, so that's just going to be 720. All right, great. So this looks like 57 squared plus 720, and that is 3969, and therefore when you take the square root, AD is 63. And there you go. We have calculated the value of AD, which they have labeled as N, and that is 63.